So equation 67 basically compute F1 corresponding to N0 equal to 2 and K0 equal to 1. Similarly, we can use another equation to calculate the intermediate vector F2, not F1, the intermediate vector F2. Again, the computation of the vector F2 depending on the specific value that you have for the pair of value N0, N1. So if you look carefully for the formula for F2 and you do the expansion on the index N1, let's see what happened. Go back to the formula that we have earlier, do the expansion on the index N1. Okay? F2. Yeah, you see the value of N1, you can have it according to our example. In this case, let me see, N1 can be having what value? Yeah, the value of N1, like you can see from equation 56. Equation 56. The value N1 can be either 0 or 1. Okay? So if you let the value N1 between is equal to 0 and then 1, then what do we have? You see, when you let the value N1 equal to 0, then you get that first term. Then you let N1 equal to 0. Now you let N1 is equal to 1. So that's why you got equation 68. Now the value of N0, which is the first subscript, it can be any value from 0 all the way to 2, I think. Let's double check the value N0. The value N0. Yeah. See the value of N0, you can see from equation 57. From that equation, you can see the value of N0 could be 0 or 1 or 2 or 3. Maximum is 3, from 0 to 3. So N0, the value, see the value N0, it could be 0 or 1 or 2 or 3. So if you let, for example, N0 equal to 2, then N0 equal to 2 is here. And let's say N1 is equal to 1. N1 equal to 1. So you take a look at N0, you replace equal to 2. N0 you replace by 2. N0 you replace by 2. And the value of N1 is equal to 1. This N1 is equal to 1. Then immediately equation 68 will become equation 69. Okay, equation 68 will become equation 69. Now notice one thing. In this situation, in this chapter, we say the number of sample data point n is equal to the product of the two integers r1 times the integer r2. However, in this chapter, we say r1 equal to 4 and r2 is equal to 2. Because of that reason, as you can see, when you compute the first intermediate vector f1, you need to have 4 data points to use from the previous vector, and they are shown in here: f01, f11, f21, and f31, as indicated in equation 67. However, if you want to compute the so-called second intermediate vector, because r2 is equal to 2, it's not equal to 4, and that's why when you compute the intermediate vector f2, you need to make use of 2 previous data points, which is f1 at n0 comma 0 and f1 at n0 comma 1. So with that observation, we can show you the graph. Well, remember again, for this situation, we consider capital N equal to R1, which is equal to 4, times another integer R2, which is equal to 2. So basically, this means we have 8 data points, sample data point. So to start the fast Fourier computation process, the function, the periodic function f, are known at these 8 specific data point, okay, corresponding to the 8 discretized time. Actually, for this case, the small index k go from 0, 1, 2 up to capital N minus 1, which means 7. Okay, that's why you have, this is a case corresponding to k equal to 0. This is the one corresponding to k equal to 1. And the last data point here corresponding to k equal to 7. However, that small index k can be expressed in terms of the pair of the index k1 and k0, as I told you earlier, based on the formula that I mentioned to you in this chapter. And so, knowing the first 8 data points, the next thing we ask ourselves is, well, how many computational vectors that we have to compute? In this case, because you have 2 integer product, that's why you have 2 intermediate vector. The first one we call vector f1. The second one is vector f2. Now, because the first integer is equal to 4, what it means is computation of any term in the vector f1, such as this term right here, such as, for example, that term f1 of 2, 1. Any term computation in the vector f1 will require 4 previous data points, and that is exactly shown in the graph, which say computation of f1 to 1 will require the previous 4 data points, which are f01, f11, f21, and f31. You see? Similarly, the computation of any term in the vector f2, because r2 is equal to 2, it means computation of any term of the vector f2 will require the 2 previous data points. So, for example, if you want to compute the intermediate vector f2 of 2, 1, it will require to make use of the 2 previous data points at location f120 and f121. Actually, this fast Fourier transform graph that you see here in figure 3, this basically is the same expression as I already derived for you for the formula to compute f1 and f2, as shown in equation 67 and 68, or as I show you in equation 63 for f1 and 64 for f2. Okay, so the FFT for the graph, it just reflects the same formula that I derived for you earlier. And this is the end of this lecture. Here is the acknowledgement.